Hi everyone. Today we will be talking about nuclear energy. So in the past few decades there has been many incidents around nuclear power plants, and while it is praised for its cleaner and safer energy than coal burning, one of the challenges that come is nuclear waste disposal. We will see how civil, nuclear, and chemical engineers comes together to make this energy safe and sustainable.
If nuclear waste is not sealed and stored properly, it can have negative effects on people's health and on the environment as a whole. In terms of the impact in which nuclear waste has on people's well-being, radiation from nuclear waste can bring on radiation sickness, a sickness that alters our DNA if exposed to high doses. Symptoms of acute radiation sickness include nausea, vomiting, seizures, skin burns, hair loss, a persistent feeling of being sick that can last for weeks. These symptoms can appear within minutes or even days of exposure, depending on how long a person has been exposed. Long-term complications include a massive increase in the chance of cardiovascular disease and cancer. Improperly stored nuclear waste can also have an impact on the environment and groundwater quality. An example of this happening can be seen at the Hanford nuclear site in Washington state, where an estimated 56 million gallons of waste are being held in 75-year-old tanks that leak a substantial amount of waste into the aquifers and into the adjacent Columbia River. This has had devastating effects on the surrounding wildlife, and radiation has impacted fish populations in the Columbia River, and forests surrounding the plant have also become radioactive. The results of these findings resulted in the largest and most expensive U.S. Superfund site in history, costing an estimated $300 to $640 billion to fully clean up, according to a Department of Energy report. This shows the sanitary, environmental, and economical effects in which improper nuclear storage can bring.
Nuclear engineers are central to the management and disposal of nuclear waste and ensuring nuclear safety. Nuclear engineers research and develop reactors, radiation shields, irradiated water filtration systems, etc. Nuclear engineers monitor nuclear plants, ensuring quality control and safety in all operations. Nuclear engineers are also involved in the evaluation of practices and procedures of the safe usage of nuclear materials and disposal of nuclear waste. Nuclear engineers will identify any design, construction, or operation practices that violate safety regulations and laws. Nuclear engineers will write operational instructions to be used in nuclear plant operation and disposing nuclear waste. They also run maintenance activities of nuclear plants. Nuclear research involves finding ways to make reactors more safe and efficient. Nuclear engineers will perform experiments to determine whether methods of disposing nuclear waste are acceptable. Nuclear engineers are involved in discovering new ways of detecting radiation, which make them responsible for nuclear safeguards and security. In an emergency, nuclear engineers have the authority to shut down any facility and analyze what went wrong and implement safety procedures.
Chemical engineers design vitrification processes for nuclear waste, a common method of managing nuclear waste where the radioactive waste is mixed with a substance that crystallizes when heated. Once heated, the water is removed through calcination and mixed with glass fragments, allowing the radioactive material to bond to the glass. This process allows waste to be immobilized in glass for many years before it is permanently disposed of. Heat and energy transfer of the waste to the surrounding environment must be precisely calculated and closely monitored as well. Chemical engineers also study channeling effects and solute transport through fractures in rocks in order to minimize the quantity of radioactive material that is released into the biosphere from the waste repositories in geological formations.
Civil engineer can help solve the problem by disposing of nuclear waste in deep geological formations. The site for a nuclear waste repository must be carefully selected so that the geology provides the natural barrier between hazardous waste and accessible environment. The disposal of the nuclear waste underground requires stable and long-lasting shafts and tunnels. All this process involves the participation of a lot of other professions. Indeed, as mentioned earlier, those engineers have to dig galleries and tunnels. But they also have to be careful towards the environment. And to not threaten the biodiversity, they must work with biologists. Also, we cannot talk about engineering without talking about the workers, who are in direct contact with hazardous materials, which can be health-threatening. To deal with this situation, the engineers are obliged to collaborate with health experts and designers to furnish the workers with medical support and equipment.